So what we're going to be talking about now are angles and how they could be related to each other when they're found between lines, usually parallel lines, these just being two straight lines or more that are travelling in the same direction. This will be denoted with the use of arrows. So anytime you see just arrows on a few lines, it's just confirming for you that they are parallel, even if the rest of the diagram is then not drawn accurately, not drawn to scale. There are then a few different types of angles, or the relationships of angles that we can find between these. For instance, if we were to have two parallel lines and just then a line travelling through them, the angle here, this inside angle, is going to be the same as this inside angle here. And this on the outside would be the same as this outside here. These we're going to refer to as alternate angles, and you can kind of recognize them by the fact that the shape between them, made up of the lines, is kind of like a Z. So this angles on the inside of the Z are the same, and on the outside are the same as each other. Next, we're going to be sticking with the same line configurations, because again, this diagonal slanting through them could be at any angle, any kind of gradient compared to the two parallel lines. The point is, because the others are parallel, they're always going to have to be the same as each other. Is that this underneath here would be the same as this angle underneath here. And so, by contrast, this on top of here is going to be the same as this on top of here. These kind of angles we're going to call corresponding angles. And they can be noticed by the fact that the shape of the lines between them kind of makes a capital F. So on the bottom side of the F's arm, if you want to call it, is going to be the same on the bottom half of the head of the F, and on top of them as well, the same as each other. Thirdly, we then have that this angle again on the inside here, not going to be the same as, because that would contradict the corresponding angles up here, but when compared with the other angle above the arm that we pointed out before, or in other words, two angles that are caught between the parallel lines and the diagonal line down between them. These two are going to add up to equal 180 degrees. So if this was 70 here, this would be 110 here. If this was 50 here, this would be 130 here, and so forth. Or that would actually have to be the other way around, because they're obtuse and acute, but you get the idea. These are going to be called complementary angles. And so this is kind of like a C, or as I say, if you prefer, just kind of have two angles locked within or between the two parallel lines. Then lastly, in terms of just how the angles between lines are going to be related to each other, if instead of being parallel, the lines are just crossing in some respects, then the angles on opposite sides of the cross are going to be equal to each other. So on top and bottom are going to be the same, and left and right are going to be the same. This we are going to call vertically opposite angles. Now, it's also important to remember in these kind of topics as well that the angles on a straight line add up to 180, as do the angles inside a triangle. Okay, so if we were just to come up with some examples then over here. So if we had two meant to be parallel lines going like that, and another line kind of slashing between them, so we're just going to confirm these are parallel by putting our arrows here. We'll say that this angle here is 120, and we're interested in this angle here, this angle X. Well, there's a couple of different ways we could actually go about this. One way would be to say that, okay, since this is a straight line, this is 120, this here would have to be whatever the remaining angle is to make it 180 degrees on that line, leaving this being 60, and then because of corresponding angles, it's the other way up to this, but it still works. We've got your slash coming through, and then the angles on the same side of the parallel lines are both on top of the parallel line. If this is 60, this will be 60 as well. X will be 60. Alternatively, we could say that because the 120 is then with this angle here between the two parallel lines, like the complementary angles, again, because they have to add up to 180, that would make this 60 here. And then vertically opposite, these two lines are crossing. If this is 60 on the right, this will be 60 on the left. Again, just confirming that X is 60. Alright, if we were to then just want to give you a chance to practice this on your own, just pause the video when you're ready and have a go, and we'll press play when it's good. So what we'll just give you here is a couple of parallel lines coming this way, but also a couple of parallel lines going this way. Now, if we were to label this angle here, what then would be this angle down here? So my advice is just try to label as many angles as you can and then just see where that takes you. Okay, so as before, there were a couple of different methods you could have gone about doing this with. Maybe you said that because this is a straight line here and this is 130, this had to be 50, which in turn would have made this 50 because these will be corresponding angles with this straight line followed by these two cutting through. They're both on the undersides. And then this, if this is 50, this X will also be 50. Again, because of corresponding angles, it's another kind of F shape just reflected and flipped over. Alternatively, you could have said that if this is 130, then this will also be 130. Again, because of corresponding angles, there's going to be a lot of corresponding angles in these potential methods. And on that note, this will be 130 as well. And then you get back to that same position of, okay, these two angles need to add up to 180 because they're on a straight line. Yeah, so there's going to be a number of methods like that. So long as you've got that X equals 50, then you should be good. Alright, and if we are indeed good with that, if we just go down to an example question, you can see here that this is now a little bit more complicated than what we were doing, but it's still working on the exact same principles. Also, just to clarify here, all of these four sides have arrows on them because AB is parallel to DC and AD is parallel to BC, hence it's a parallelogram. However, they have a different number of arrows just to make it clear that AB is only parallel to DC and AD is only parallel to BC. Alright. Now here, we are looking to work out the angle X. It's not going to be so simple as just do one little, say, okay, this angle is the same as this angle, or so forth. We're going to have to work out a few more, like I suggested with your question. Fill in as many angles as you can and see where that takes you. For instance, if we just look at this top triangle here, before we even get into any of the main four rules I listed above, your triangle ABD was a triangle. The angles have to add up to 180. So we already have 120, and we already have a 38. So if you take both of those away from 180, that leaves you with this angle in this corner being 22. Now at this point, we might notice that our sides going from A to B, down from B through D, and then to the right towards C, this is making a kind of Z shape. So it's going to be an alternate angle. So if this is 22 up here, this is also going to be 22 here. Okay, I'm just going to clear that up a little to give us a little bit more space, so long as we're clear on that's what we just did. Next, we'll then just want to work out what this angle on top here is. Well, actually we were just saying that BD is going to be a straight line. Because it's a straight line, this 41 add whatever the angle I've just put in red is, will have to add up to 180. So 180 minus 41, that's going to leave us with it being 139. Lastly, therefore, once more, we actually just have a triangle is 180 degrees. So 180 minus your 139 minus your 22, that's going to leave us with x here being 19 degrees. You could have done this